On that question, they're giving us 63.52% iron and 36.48% sulfur, right? So, 63.52 for iron and sulfur is 36.48, right? In percent. And what am I going to divide each of these by? Yeah, so for iron it's like 55.847, right? And for sulfur it's 32.066. I'll give you a second real quick, and why don't you find that quotient, that division, from that step. Did we get about the same number for both of them? So divide both sides by the smallest one, which is the 1374 ending number. And you can tell, or you could do it in the calculator for a double check, but it looks like they're going to be 1 and 1. So it's going to be 1 iron to 1 sulfur, so FeS. Cool? So empirical formulas are not too bad. Let's look back at the beginning page, and we'll just go through several of these. Let's look at question 9. It says, which of these has the smallest molar mass? So on this we need to find the molar mass of each compound. So let's find that real quick for KCl. For calcium oxide. I think our choice is pretty obvious once we find it. All the molar masses. What is our choice? It's literally saying the smallest molar mass, right? So we went with the one that is the smallest number. Cool. In this problem, what are we starting with? Moles of AgNO3, right? And where are we going to? Grams. So, off to the side. I think we need to draw this out. Remember, moles is always in the middle. Mass is up top. Particles is on bottom. Draw it out like this each time, I think. That would be our best bet. And where are we starting at? I'm sorry, what? Moles. Starting there. And where are we going? Up or down? Because we're going to grams, right? That's going to be one step. We were talking about AgNO3, and it didn't seem like we were talking about a specific element. We were talking about the entire compound. So what unit has to go down here? Of what? And we know that at this conversion step, 1 mole is equal to the molar mass. And can someone tell me the molar mass? So 169.817? 872, okay. Grams of AgNO3. So we're going to multiply those numbers across. 1 mole was equal to that 169.872 number. So 2.53 times 169.872. And I got 429.77. With sig figs, you could write 430. You could put the point there if you wanted. That's pretty close. Now tomorrow's test is multiple choice. So you know I'm not going to be tricking you like with the 429 and 430. One of the answer choices is going to be 430 or right around it. The other choices are just going to be way off. But I got 429.77, which rounds it up to 430. But what I'm saying is that on a multiple choice test, maybe answer choice B would be 430, and A, C, and D would be way off. they'd be like 700 and 300 and 4,000. You would know that you've done it incorrect. 430 grams of AgNO3. Cool? Then let's look at the next one. What are we starting with? So moles, right? And what are we going to? Which is a type of particle, right? So we're going down. Now, a formula unit is referring to a compound. Did they ask me about a specific atom? So I'm not going to do that unique step about breaking down the compound. 14.32 moles of H2SO4. And a mistake that I would not want you to make is you spending your time finding the molar mass. Remember, molar mass is to convert between mass and moles, right? 1 mole is equal to molar mass right there. Where are we starting at in this question? Moles? Where are we going to? Particles or mass? So do you even need to find the molar mass? No. What unit's got to go down here? Perfect, of H2SO4. 1 mole of it, 6.02 times 10 to the 23rd. Particles, which would also include a formula unit, on top. So 14.32 times 6.02 to the power of 23. 8.621 times 10 to the 24th formula units. Good? Now, what is so special about question 12?
Only wants to add them up from potassium.
Yeah, exactly. So we have to break down the compound. We have to have that special step in there. We're starting with mass, so that's 111.92 grams of K2O. What unit needs to go down here? Grams of K2O. And the molar mass, right? 39.0983 times 2 plus 15.999. I got something like 94.1956. Is that what y'all got? What goes on top of that? Very good. 1 mole of K2O. And this is the special part, right? What do I got to put on bottom of K2O? And what's going to go on top of that? Hopefully we all catch that valuable step there, because in this step we're breaking down the compound. Breaking down the compound in this step. Am I done? What's going to go on bottom? Or just K? Because we only got K right now, right? And then on top of that comes 10 to the 23rd atoms of K. I got something like 1.4306, give or take, times 10 to the 24th atoms of K. Is that what y'all got? Cool? Was I going to atoms in this problem? So I didn't see the special atoms step, did I? Okay, so 65.43 divided by 28.01 times 6.02, second E23. Sig figs included 1.406 times 10 to the 24th molecules of CO, right? Raise your hand if you got this answer. Very good. Okay. Number 15, right? It says how many atoms are in 1.00 moles of H2O? Did I ask you about atoms of H or atoms of O? I asked you total atoms, correct? Watch this. This is a different style. Are we all watching? Because Mr. Fields is. We made a promise earlier. Okay. 1.00 moles of H2O. And for every 1 mole of H2O, how many atoms do you see in that compound? How many? No, I'm saying it says total atoms. You see 3 atoms, right? 2 H's and an O. So that would be 3 moles of atoms. 3 units of atoms. And we know that I still got to put 1 mole on bottom and do my 6.02 times 10 to the 23rd atoms on top. So that would be basically 3 times 6.02 E23. Y'all see that?
Where you getting the 3?
Because in H2O, there's an H, and an O. That's where the 3's coming from.
It's
Good.
only for H2O?
I could have, what if I had said, I'm going to do a pretend, okay? I'm going to do a pretend right here problem. You ready? Maybe you want to like find some space off to the side or whatever. You can write this one down. How many atoms are in 5.3 moles of Al2SO4 3? Question mark, question mark. Y'all ready for this? I'll let you copy it down, and then we'll go over it. We're starting out with 4 moles of NaCl. And what are we going for? What is it asking us for? The most what?
Mass.
Mass, okay. So I'm going to go to mass by doing 1 mole on bottom. And the molar mass on top, which is 58.443 for grams in NaCl. And that's going to be some number, 58.443 times 4. That's something like 230 grams. Okay, then H2O is 4.0 moles of H2O. And 1 mole of H2O is going to be how many grams? 18.015, right? It's the molar mass of it. Correct? That's going to be about 72 grams of H2O. For CaCl2, starting out with 4 moles of that. 1 mole of CaCl2 is going to be what? 1110. So yeah, you get something in the 440 range. CaCl2, cool. And then CO2, 4.0 moles of CO2. And I know that 1 mole is like 44 grams. So 44.009 times 4. I got about 180, right?
176.026.
With the 2 sig figs, so about 180.
Yeah.
CO2. It says which do have the most mass? Obviously the C part 1. Right? That was just like 4 problems embedded into one. Be ready for something like that too. Question, ma'am. And you took the biggest one, and that would work because you're multiplying by the molar mass in this step. Now, but I would say if it would be reversed, if it said which do you have the most moles of, then you would be looking for the smallest molar mass. So I think you might want to just do this problem off to the side, because if it was reversed, I'm not saying it is or isn't on the test because I don't know and I don't remember, but think about it logically. Your strategy on that part was right. Kind of, yeah. Let's look at 17 real quick. Why don't you take some time, and now you can recognize that in a problem like that, you basically just have to do, yeah, you just got to figure out the most moles of metallic atoms. So, I have 100 grams of NaCl. What do I have to do first to get that into moles? Divide it by its molar mass, right? Which is 58.443 grams of NaCl. What's on top? 1 mole, right? of NaCl. And I'm supposed to be finding moles of non-metallic atoms. What's the non-metal in this compound? Na is a metal because it's on the left side of the periodic table. Non-metals are on the right side, so for sure the Cl is the non-metal. 1 mole of NaCl, there's 1 mole of Cl in it. Do you know where I got this 1 for 1 mole of Cl?
Yeah.
Because there's 1 Cl in NaCl. 100 divided by 58.443, that's 1.7 or so moles of Cl. Let's go on to the next one. 100 grams of Cl2. What's the molar mass of Cl2? About 70.906. Cl is like 35.45 times 2. It's going to be 1 mole of Cl2. And in 1 mole of Cl2, how many moles of Cl do we have? How many moles of just chlorine do we see? We see 2 chlorines. About 2.8 moles of Cl. Now I'm gonna skip question or part C. Can someone tell me why I'm just gonna skip it? It's a metal. Na is got only a metal in it. It's only a metal, so I would skip it because it's not even gonna have. It's gonna have 0 non-metal atoms in it. So I'll just do D then. 100 grams of S. That's just lonely little S. What's got to go on bottom? 32.066 grams of S for every 1 mole of S. And can I break down S any further? No, there's just S in the compound. So 100 divided by 32.066.
3.119.
So about 3.1. They were asking for the most moles, right?
Yeah.
Which one wins? D? 3.1, 2.8, 1.7? The 3.1 wins. Cool?